So here I'm going to walk through practice task 3.3. The main objective of this task is to get you comfortable with how to use Excel to convert complex number between the two different forms, the rectangular and the polar forms. I would like to draw your attention to the back page of the project, which talks about these complex number functions in Excel, which are going to be an important part of developing the spreadsheet. And you can see all the kinds of operations that we've done have built-in Excel components. So the first thing is, this will be an important one, complex number. Complex numbers aren't automatically recognized by Excel, so in order to create one, we have to use this function complex. I'll show you that in a second in the spreadsheet. But then you have these other types of functions here where this next one, IMABS, calculates the magnitude of the complex number z. So if we have the complex number sitting somewhere in the cell and we want to figure out its radius or its absolute value, which is the same thing, we can use this function. Same thing with the next one. If we want to just find the angle of a complex number rather than going through all the conversion formulas, we can use this function in Excel. And so we want to use leverage the power of the technology here to do whenever we can. You can see over here there's these degrees and radians. This will actually just do conversions between radians and degrees for us. We don't have to program it to do the 180 divided by pi or its reciprocal. So if I move back to the Excel spreadsheet, the first set of tasks here, essentially we want to fill in the values any place there's yellow in here. So the first half here, you can see we're given essentially numbers in polar form where the numbers in degrees. So for example, this first row here is the complex number 4 cis 180, which we know to be -4 if you visualize it. And so I guess the first thing to practice here is if I want to fill in the theta in radians, and we have degrees here, I need to create a formula to go ahead and do that. All formulas in Excel need to be started with an equal sign, so that's the first thing I'm going to put there is equals. And if we go back to this function sheet here, we can see that the function is radians. So if we just use equals radians and the angle, it'll convert for us. Come back to here. So if I just say equal radians, and actually you can see it starts to fill it in for me, converts degrees to radians, so equals radians, then I do a left parenthesis, and then I'm just going to click over into this cell, and so it's going to say whatever numbers in E5, convert that to radians. So it sees 180 in there, and boom, looks like pi, so that looks like that worked. And if we want to copy things down, just like we did in practice task 3.1, we can just drag this down and it'll preserve the relative cell references. So if we, for example, look in this cell, it says equals radians E7. So when I copied it down, it essentially was saying take the value to my left and convert it to radians. And that's what happened there. So I'm just going to go ahead and use that for all of them. You could have done this a different way if you wanted to actually do the actual formula. You don't have to program this in your spreadsheet if you don't want. You can just look on here. But if I had an alternate version, I was going to label that. Another way I could have converted is if I wanted to do the math myself, I could have just picked, I'm just getting the degrees, and then I could have multiplied it by my own fraction, pi over 180. And in Excel, pi, you do the word pi with 2 parentheses next to it, and then it knows you mean pi. And then I would divide that by 180, and that should give me the same value, and then I just could copy that down. That's just, again, just an FYI. You can program spreadsheets to do things differently if you want, but we want to harness the technology's power here and just use its built-in function. Now to get the rectangular coordinates from polar, you may remember our conversion formulas from the toolkit. The x coordinate is just going to be r times the cosine of the angle, and we can just go ahead and program that formula. Let's look back at this appendix sheet here to see what we're going to use here. Cos here is a function we're going to need here. It computes the cosine of theta given in radians. So as long it's going to basically we have to give it an angle in radians, and it'll tell us the cosine if we use that function. So here, if I do the equal sign, again, I'm starting a formula with that, and then I'm going to go ahead and get the cell reference where this radius is, equals d5. Multiply that by cosine left paren, and the number I need here is the radian version, which is in column F or F5. And then I'm going to close that parenthesis and then hit equals. And so that's just it equals this, the number in d5 times the cosine of the number in F5. And the advantage of programming it this way is if I go ahead and just drag that down, it's going to preserve those relative cell references. And and like for example here in row 9, this was sys0. I'm sorry, this was using the value in D9, which is what we wanted, and the value in F9, which is also what we wanted. Notice how you see here in A8 kind of this crazy version. I call this the crazy version of 0. It's e to the negative 16. So what we'll do, just to do a little formatting here, is I'm just going to highlight this, and then if I go to the home screen, I can just click on up here in the number formatting, comma style, and then I can choose how many decimal points I want by clicking on these arrows, and so it'll look more friendly when I do that. And it looks like it's showing negative signs with parentheses, which is not uncommon in like accounting applications. But as I think about it, this is not an accounting application, so let's make this look more like we want it to. So I'd go to the same spot here, and then I would just pick a number like this. And then I could still pick the 4 digits. That's what we want. Okay, and then for the imaginary coordinate, that's the y value. That's just going to be the sign. So we can program a very similar formula, equal sign. I'm going to come over here and click D5 for R. So you can see it's showing cell reference D5 times the sign, and again, returns the sine of an angle. Sine does need to be in radians, so we're going to use the radian version of the measure. Got that. I'm going to copy that down. Again, we have the same formatting going on here, so I'm just going to highlight that area, click number, format, and let's go to 4 decimal points to see. And so here we have the real and imaginary coordinates created from the sys form. If I wanted to if I wanted to make the complex number, that's going to be something we're going to need to do. I'm going to just show you how to do that. So off to the right here, I'm going to create a little section called complex number, and go back to here, complex AB. It creates the complex number A plus BI. So that's what we're going to do here. So if I just do equals complex, you can see what it does here. Converts real and imaginary coefficients into a complex number. So complex, left paren, I'm going to grab the value in A5, comma, the value in B5, close the paren, and you can see that we have the complex number created. And there's unfortunately no way that I know of to format the decimals with these complex numbers, so you get these crazy, really long decimal numbers, but that's just sort of something you have to put up with for this project. But when you see the graphs, it's not going to really matter, because everything will just be, it'll be shown on a rounded basis. Okay, so let's move on to the second set where we're given everything in rectangular form and we want to go ahead and convert to polar. And again, there's a number of ways you can do this. I'm going to just show you the way where we're going to use the functions from Excel. So the first thing I want to do here is I want to create the complex number. So I'm going to go ahead and use the same column that we just created here called complex number. And in fact, I can just go ahead and copy it from up here because it's going to preserve those relative cell references. So I'm just going to say click on cell I5, right click, copy, come down here, right click, paste, and it's created the complex number 3 plus 4i, which is what we hoped for here because the coefficients, real and imaginary, are 3 and 4. Go ahead and drag this down, which will copy it for all the values here. So now we have all these nice complex numbers created. So now we want to find the radius and angle of these rectangular complex numbers. And there's functions in Excel to do that for us. That's these first two that I talked about at the very beginning. Calculates the magnitude of the complex number z. That's the first one. And then im_argument calculates the angle of z in radians. So here, if I want to do r, I can just do equals im abs, returns the absolute value of a complex number. And now you can see why I've created the complex number off to the right here, because I'm going to use that in my formula. And it's 5, which makes sense. It's a 3, 4, 5 triangle, and that's r. Go ahead and copy this down for all these, and it's going to give me the radius or the absolute value for all the numbers in my set here. And I'll come to format number, 4 decimal points. So now I have the radius. I need the argument in radians, or the angle in radians. Again here, im_argument calculates the angle of z in radians. You can see where this is going. I'm going to do equal sign im_argument returns the argument q, an angle expressed in radians. Left paren. I'm going to give it the complex number we created as its input, and that's the angle in radians. Copy that down. Well, you see here this #div0, we see a divide by 0 error, which makes sense because look what our input number is. This is 0 plus 0i. There's no angle that can be defined for that. And so it's just it's reporting an error for us, which is fine because it's a number that doesn't work for the conversion anyway, because it could be any angle. Go ahead and move this down to 4 decimals. And if we want the degrees here, we can go ahead and use the degrees function. So equals degrees. And we're going to click over here to F11, get the value there. Go ahead and get this down to like 1 decimal point. 53.1 degrees. Move these guys down. There's still an error here, but if we look at this one is 10 plus 0i. That's on the real axis, so it gave us an angle of 0 degrees. Looks like that worked. And you can verify for yourself that all these other ones work too. So you can see that we quickly were able to do all these conversions using formulas in Excel. And I'll leave it for you to practice on this last one here, which is just a version of the one we did up here, except now things are given in radians instead of degrees.